In this video, I'm going to show you how to find the gradient to a curve at any point. And that means, of course, finding the tangent to the curve at any point. And what do I need? Well, I need the curve drawn on a sheet of paper, a protractor, a pencil, a ruler, and a plane mirror. And the plane mirror is mounted so that it is at right angles to the plane of the paper on which the curve is drawn. Right, I'm now going to put the mirror across the paper so it intersects the curve. And you can see that you have a reflection of the curve in the mirror, but that there is a change of direction between the curve and its reflection at that point. Well, I'm now going to twist the mirror so that there appears to be no change of direction. But of course, I've gone too far, quite deliberately, and you see again, I've now got a change of direction. But this time, I'm going to move it back now gently so that a point should be reached where there is no change of direction. And this you have to do by judgment. Now, I think that's quite good. I think that moves quite smoothly, the reflection and the curve. It's very tricky to get just right. I think that's it there. What have I found? Well, what I've found is the point where the mirror is at right angles to the curve, because the curve and its reflection pass smoothly one into the other. So I'm now going to mark the position of the mirror very carefully at the back here, there and there. And now take the mirror out of the way. And using the ruler, I'm going to mark this line. And the line I'm marking is a line that will be at right angles to the curve at this point. So there it is. Now with the protractor, and you can do this at any point along the line, if I make just a point here, I will be able to draw a line like this. Now you can see that that line is going to be at right angles to this one, and therefore this line here is going to be a line which is tangential to the curve. Just to prove that to you, if we put another line there, actually at the edge of the curve, you see these two lines like this are, those two lines are parallel. It's sometimes easier to draw one out here away from the curve itself, but believe me, that line and that line are parallel. So let's now find the gradient of this line, or this one. Maybe you'd prefer to me to do the one that actually touched the curve, so we'll take this one. Right, so we'll do from this point here, this point there, and therefore there. Now, the y value here is 5, 10, 15, 20. Well, that's nice, exactly 25 units on my scale that I've done here. So 25 for the y value, and the x value, these are 0.2 each of the squares here, so that's 0.8, 1.8, 2, 2.2, 2.4, I think 2.5. Let's just check that. 0.8, 1.8, 2, 2.2, 2.4, 2.5. So well, that's surprising. 25 divided by 2.5. The gradient then is 10. Believe me, that's pure chance. So the gradient of this curve at this point is 10. And if you look at the labels on the two axes, I've just got a temperature time graph here. So it is 10 degrees centigrade per minute at this point. So this object was cooling at 10 degrees centigrade per minute at that point, which was at a time after the start of about 1.5 minutes.